Unit 3 Chemistry, Chapter 3, Part 2, Gas Equations. So, we said in the last video that we know the molar volume of gases at these two conditions, STP, standard temperature and pressure, and SLP, standard lab conditions. That should be a C. We know that for both of those we have a pressure of 101.3 kilopascals. For STP, we have a temperature of 0 degrees Celsius. For SLC, we have a temperature of 25 degrees Celsius. Okay. Now, if we know that, then we can use this to find the amount in mole if we know the volume that we actually have. Okay. So we know that the amount in mole of a gas is equal to its actual volume divided by this molar volume. Okay, and these are our two molar volumes, because it only works for those conditions. Okay? Or, if we know the amount in mole, we can use this to find the volume. So if, for instance, we know that we collected 2 litres of hydrogen gas, and we know that reaction was from a reaction of magnesium and hydrochloric acid at 1 atmosphere and 25 degrees Celsius. First thing we go is, okay, 1 atmosphere, 25 degrees Celsius, what is that? Well, that's SLC. Okay, so we say N equals V over Vm, so it's 2 litres divided by 24.5 litres tells us that in that 2 litres there was 0.082 moles of hydrogen gas. Now that works great, but it only works great if we've got STP or SLC. If not, we've got a second equation. This is the ideal gas equation. PV equals nRT. So this works for any temperature, any pressure. Okay? The pressure in kilopascals times the volume in litres is equal to the number of mole in mole times the gas constant, which is this number down here, and is in your data book, so you don't need to remember it, times the temperature in Kelvin. So any gas which has this exact relationship is called a perfect or an ideal gas. And as is the case with all things, there is very few things in the world that are perfect or ideal. Real gases will follow this equation when the particles are most spread out, which means low pressure and high temperature. Okay? So, if we want to use the ideal gas law, we would say what amount in mole of gas will occupy a volume of 26 litres at a pressure of 104.2 kilopascals and a temperature of 291 Kelvin. Okay, so PV equals nRT. We plug in our values from our question. N is our unknown, and 8.31. It's not in our question, but remember that was our R. That was our gas constant, which is in your data book. Then we simply rearrange, and we would find that that would be equal to 1.12 moles. Okay? Now notice we didn't have standard temperature or standard pressure, but this equation still works.